55 years ago, on July the 20th, 1969, Apollo 11 touched down on the surface of the Moon, marking humanity's first steps on another celestial body. This monumental achievement was powered in part by an innovation pioneered in the Department of Chemical Engineering and Biotechnology of the University of Cambridge.
Francis Thomas Bacon was an inventor and an engineer who worked on invention of the fuel cells for quite some time while working at the Department of Chemical Engineering and Biotechnology at Cambridge.
It was almost as revolutionary as the discovery of steam traction. Would you agree?
Well, I like to think so, but you must remember that I'm an enthusiast, and perhaps you better get that confirmed by somebody else.
Today, the Energy Reactions and Carriers Group, led by Dr. Ava Marek, continues the spirit of innovation demonstrated by Bacon with their work at CEB.
We're looking into alternative ways of storing hydrogen. So you can store hydrogen, for example, in chemicals. So hydrogen can be a building block of a chemical. If you decompose that chemical, the hydrogen is being released. We're using something that can contain a lot of hydrogen in the molecule, and that usually are very dense hydrocarbons. If you decompose that, then you can have much more hydrogen per molecule of your starting component. If we are successful to introduce new energy carriers such as hydrogen or ammonia, we can then use these energy carriers instead of fossil fuels, and that will allow us to generate electricity and heat without petrochemistry, without fossil fuels, and in an environmental friendly way. A hydrogen-oxygen fuel cell is an electrochemical device that produces electricity by splitting the provided components, which are hydrogen and oxygen, into ions and electrons. And that splitting happens at two different sides of the fuel cell. The electrons leave the fuel cell through an external circuit, generating electricity, while the ions flow from one side of the fuel cell to another, ultimately combining and producing water. So if you don't have access to electrical grid and you want to produce electricity, then you can use fuel cell. It's lighter than batteries, and it can produce electricity as long as you have access to hydrogen, oxygen, instead of batteries just having a specific lifetime and then you need to recharge them. What made the fuel cell very attractive to NASA was the fact that it was able to produce high power at high efficiency in a very reliable and safe way and operating flexibly. So Bacon, when he invented the fuel cell, he really believed we can use the fuel cell to generate electricity from hydrogen in a sustainable way, away from petrochemistry and fossil fuels. We want to produce new types of energy carriers that are carbon-free, so we can generate electricity, generate heat without destroying the environment. That's the benefit goal, without releasing CO2.
55 years on from Neil Armstrong's small step, the Department of Chemical Engineering and Biotechnology is still aiming for the stars, with cutting-edge research to power the next giant leap for mankind.